In question 5, you were asked to write both an explicit rule and recursive rule for the sequence. Let's start with an explicit rule. With explicit rules, you need to be able to sub in a number directly and get that specific term. This is your n equal to 1. This is your n equal to 2. This is your n equal to 3, n equal to 4. If I sub in a 4, I should directly get this term. So when I do the explicit rules, I always think about what am I doing to n to get to that term. And notice in all of these n values, the numerator is never affected by n. The numerator is always 2. The denominator, however, is changing. You need to connect the n value to that specific denominator. Notice that in the first term, I have 5 to the first power, 5 to the second power, 5 to the third power, 5 to the fourth power. So in other words, the n value is the power for this base of 5. This is your explicit rule. If I want to find the fourth term, I just sub in a 4 and notice it takes me directly there. Now, recursive rules are very different. Remember I said for a recursive rule, you have to tell me what the first term is. Then from there, to write the recursive rule, you need to have that a sub n minus 1. So if I want to find the second term, I need to know what the first term is and what am I doing to the first term to get to the second term. So instead of looking at the n value, kind of ignore that, just think about what do I do to this first term to get to the second term. Well, I don't change the numerator, but the denominator is getting multiplied by 5. Notice for the second term, what do I do to the second term to get to the third term? Again, I'm multiplying the denominator by 5. Do you see how you're focusing on what are you doing to the first term to get to the second? You're not thinking about n. It doesn't matter which term it is. It's what are you doing to the previous term to get to the next term. So with that being said, I'm basically taking the denominator and multiplying it by 5. So you take the previous term and multiply by a fifth, and that would be your recursive rule. Now, for question 6, you are being asked to determine if a sequence is convergent or divergent. There's different ways you can do this. You can actually just start filling in values for n and start thinking about what you get when you do that. So, for example, if you want to take your calculator and you want to sub in n equal to 1, so what I could do is I can take 4,000 and I can do negative 1 divided by 4 raised to the first power. I can find that when n equals 1, I'm at negative 1,000. And that when n equals 2, I can do this again, so I can enter, but change that to a 2. I get 250. And that when n equals 3, I can do this again. I get negative 62.5. So what you're seeing is that because you keep multiplying by a fourth, you're seeing these numbers are getting smaller and smaller. Now note, you can go and do this again, but now change this to a 500. Check what's happening to these numbers. Notice it's saying it's approaching 0. Now technically it would never equal 0. It's just getting so small that the calculator rounds and says it's 0. But what you should see is that this is converging to 0. It doesn't matter that one of the numbers is negative, one of them is positive. It's this idea of, if you go back to the notes, what you're seeing is that it is approaching this value. We're seeing it converge. It's just going positive to negative, but it is approaching that value, and it would be at 0. So this is what we say is converging. Now, you can also go to your calculator and you can type this in, but I'm going to warn you, you don't want to graph these. Sometimes these aren't functions, and this one right here actually, in some cases, is not a function when you think about different values of n, like radicals and things like that, or rational exponents, I mean. But if you go to your table, you're going to see that as we get larger values of n, this is the best and easiest way to see it, you're going to see that these are approaching 0, going positive, negative, but it still is approaching that value of 0. So this does in fact converge. So if you want to try to use your calculator and try parts B and C and then restart the video, I'll go through those as well. So for part B, let's see how you did. you can take this negative 2 and raise it to the x power. And then we want to divide that quantity by 2. If you go to your table, just check to see what's happening. Notice that as n gets larger and larger, these values get larger and larger. They're not approaching a value. Oh my gosh, what am I doing? They keep getting larger and larger, one time negative, one time positive. This right here is going to diverge. And then finally, this last one, I'm going to use a good number of parentheses here. I'm going to say, first of all, parentheses for the entire numerator. So 0.1, oops, that's not a 1. Raised to the x power times x. And then I'm going to close the parentheses around the entire numerator, divided by, and then do the same thing for the denominator. Notice, oh, come on. Notice I'm hitting every single, oh my gosh, I give up. All right, let's keep going, to, and then we're going to say x minus 1. Now, if I go to my table, you're seeing that, again, these values are getting smaller and smaller and smaller. Oops, sorry, I'm all the way in the negatives. You know, many people would probably stop this video and re-record it, but I'm going to go with it. But you're going to see, yeah, these numbers are going to be very, 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 very small, and they keep getting smaller and smaller and smaller. But notice that that is getting closer and closer and closer to 0, because you're basically just moving that decimal place one more to the left every time, making this closer and closer and closer to 0. So we're going to say that this converges to 0. Now, this final problem on here is about a vacuum pump removing 15% of the air from an air mattress. And we're starting with 20 liters of air. So notice that this is like last unit. This is an exponential problem, and in fact, it's an exponential decay. You're removing 15%, which means that 85% remains. So if you want to find the first 3 terms of the sequence, think about the first term of the sequence is going to be when we take that 20 liters of air and we remove 15%. So you can either say 1 minus 0.15 because it's decay, or you could just multiply it by 0.85, and that will represent 85% that remains. So let's go back to our calculators here. And we get 20 times 0.85, and then we have 17 liters. Now, you can either use this formula we created in a sense, and think about now you would have to take the 20 times the 0.85 and raise that to the second power, or just take this new answer we got and find what 85% of that is. So then we could take that answer times it by 0.85, and that would give us 14.45 liters. And then we can do this one more time to find that third term. Just take the answer we got. Oops, I don't need parentheses there. 0.85. And then that'll give me what 85% of that amount is. So we're seeing approximately 12.28 liters. So that would be the first 3 terms of the sequence. Now, if you wanted to write both an explicit and recursive rule for this, let's talk about explicit first. Remember, with explicit, you need to be able to sub in a 3, and that gives you the third term directly. So note that this is really just an exponential equation where 20 is the initial amount, and we're multiplying by this 0.85. Now, all I have to do is put n up there, because if you think about it, if I want to find the first term, I sub in a 1 for that. If I want to find the second term, notice that that would just be taking 20 and multiplying by 0.85 2 separate times. And notice that that would take me directly there. Or if I take 20 and I multiply by 0.85 to the third power, that's going to take me to that third term, because I keep multiplying by 0.85. Here's 0.85 a second time, 0.85 a third time, and that's how I'm getting that answer there. Now, if you wanted to write a recursive rule for this, Remember that we have to say what is our first term, so a sub 1 equals, and for this one right here, we're going to say that that first term was 17. And then notice that from there, we need to say what the rule is to get to the next term. So in order to do that, we need to use the previous term and think about what do we do to 17 to get to that second term? Well, we're multiplying by 0.85. And that would be your recursive rule for the sequence. Now, technically, you could say a sub 0 equals 20, and you could use this idea to say then that the next term is the a sub n minus 1 times the 0.85. This would also work. It just depends on if you wanted to include the 20 or just use the 17 that we first found. Either one would be acceptable. Now, is this going to converge or diverge? Well, think about eventually, yeah, this number is going to get very, very close to 0. And you're going to see that the air mattress is eventually going to deflate. Now, will it equal 0? Mathematically speaking, no. But we will see that this will converge to 0.